The paper of the day is End-to-End Arguments in System Design. This paper presents a design principle that helps guide placement of functions among the modules of a distributed computer system. The principle, called the end-to-end argument, suggests that functions placed at low levels of a system may be redundant or of little value when compared with the cost of providing them at that low level. Examples discussed in the paper include bit error recovery, security using encryption, duplicate message suppression, recovery from system crashes, and delivery acknowledgement. Low-level mechanisms to support these functions are justified only as performance enhancements. The end-to-end argument states that some functions may completely and correctly be implemented only on an application level. Implementing said functions completely and correctly on a platform level is not possible. This impossibility is rooted in the fact that the application layer has total information. The platform layer may only have some partial information. Informally, the platform layer lacks context. However, the end-to-end argument does not preclude to provide a partial incomplete implementation of a function or to duplicate a function on a platform level, not for completeness and correctness, but strictly as an optimization. In addition, the paper stresses that the end-to-end argument is a guideline that helps in application and platform design analysis. However, identifying the endpoints to which the argument should be applied requires subtlety of analysis of application requirements. Considering the example, the significance of the end-to-end argument is most apparent when reasoning about layers and failures. Is the layer able to detect a failure? If a layer is able to detect a failure, what should the layer do? Should the layer mitigate the failure? Should the layer present the failure to the next higher layer? Let's discuss one of the examples, that is reliable file transfer. The object is to move a file from computer A storage to computer B storage without damage. A popular implementation to transfer a file is to transfer the file in chunks. On the sender side, the application layer splits the data into chunks before handing each chunk downwards to the platform layer for transfer. On the receiver side, the platform layer receives a chunk before handing the chunk upwards to the application layer for assembly. So as you can see in the diagram, there's a target source and there's a transfer target. So there's a source file, target file, there's an application layer, it's chunked, and then it goes to the platform layer, it does a transfer, platform layer receives it, then gets the chunk, application layer combines the chunk and writes to the target file. So now the question arises, can you implement file transfer completely and correctly by limiting failure detection and failure mitigation to the platform layer, or do you need failure detection and failure mitigation on the application layer? Failure detection and mitigation. While the platform layer may indeed detect transmission failures of chunks via checksums on chunks and mitigate failures via retransmissions of chunks, only the application layer may detect assembly failures on files via checksums on files and mitigate failures via retransmission of files. Failure presentation. While the platform layer may indeed try to mitigate transmission failures via retransmissions, eventually in order to avoid an infinite loop, the platform layer has to present repeated transmission failures to the application layer. In summary, although the platform layer implements partial failure detection and mitigation, ultimately only the application layer is able to implement total failure detection and mitigation. Only the application layer may determine if a file transfer was a success, was a failure, and how to handle that failure. Conclusion. The end-to-end argument states that some function may completely and correctly be implemented only on an application level, even though the end-to-end argument does not preclude partially implementing functions on a platform level as an optimization. For example, failure detection and mitigation of a failure file transfer can and should happen on an application level and a platform level, but only the application layer can ensure the completeness and correctness of the transfer.